Assalamualaikum and a very good day to the SSS and everyone. Today, I am attending the 2021 9 IEEE Conference of System, Process and Control, and I will be presenting my study regarding the impact testing of magnetorheological elastomer, barometric material and magnetic particles that prepared by me, Normidatus Halwa binti Sobri, Diazul Zakri bin Baharudin, Nur Akmal binti Hanifah, Dr. Zulkifli bin Abdul Kadir, Associate Professor Dr. Hizbullah Huda, and Dr. Muhammad Sabirin bin Rahmat. So I will start my introduction. There are many smart materials known as responsing material developed by scientists and engineers to ease daily life and reduce the risks that facing frequently. One of them is magnetoactive or magnetorheological materials that are usually made up of micron-sized ferrous particles distributed in a carrier fluid or elastomer. The classification of this smart material is MR fluid, MR foam, MR gel, MR elastomer, and more. MRE, which is magnetorheological elastomer, is from the branch of the magnetorheological materials that possess magnetorheological properties. The magnetic particles play an important role in magnetic field dependent properties because these particles are very sensitive to the magnetic field that will affect to the manufacture MRE. So this is the uses of MRE in impact mitigation application. The first one is the dynamic vibration absorber, where MRE is located at the electromagnetic coil winding. And the next one is the force sensor. And the third one is the isolator system, where MRE also is located near to the coil. This is because of the magnetic field. So my study starts with the fabrication of MRE. MRE has three main components. They are rubber, ferrous particle, and binder. In my study, I will be using the varying of composition of ferrous particle, which is 50%, 60%, and 70%. The fabrication starts with manually mixing of the all components into a container, and then the mixture will be poured into a mold, and the mixture will be cured for about 24 hours, and the cured MRE will be put into the MRE test device for impact testing. So this is the materials and the parameters that I will be using in my study. So the material for ferrous particle is the carbonyl iron particle, which I'll be using for 70%, 60%, and 50%. And the rubber that I use is RTV silicone rubber. And the binder that I will be used is the resin. The parameters for the impact testing is where impact energy is 11 joule, impact velocity is 2 meter per second, falling height is 204 millimeter, tub holder mass is 4.3 kilogram, tub nominal mass is 1.2 kilogram, specimen support is 3 mm, and a varying current from 0 ampere to 2 ampere with 0.5 step. So this is the drop impact test setup, which include the PC setup, the DAQ, and the drop impact test showing the MRE suspension system. This is the results, which is the fixed current with various composition. By comparing the result of varied composition from 0 ampere to 2 ampere, the maximum force at the first peak exhibit an increment pattern as the current increases. However, it is unrelated to the composition. The maximum force recorded the highest value for 60% composition for all current and without disappointment is the highest among the others too. As a result, the force experienced by the MRE will be greater since the MRE tends to absorb more energy than the other and provides a rather accurate answer to the purpose of the study regarding the link between force and current. The magnetic field is induced when the current flows through a coil bobbin and aligning the magnetic particles. This result incidentally proves that the optimum composition is 60%, followed by 70% and 50%. The optimum composition is determined by the maximum force exerted on the MRE samples, as explained earlier. Next one is the experimental result for various current. This result displays the same pattern as discussed earlier. About 5,838.24 Newton force achieved by the 60% specimen when induced by 2 ampere of current. The tensile and shear strength is higher in the 60% composition of the specimen coming from the impact force. The optimal composition of 60% demonstrates that the higher current supplied created stronger magnetic field and will strengthen the interaction between interparticles and rubber matrix among all composition. Thus, the force exerted on the MRE samples is greater since the tensile strength within it is greater, and it is because the bonding of the material is considerably tougher due to the magnetic field. So the conclusion is the optimal composition for MRE in this study is consists of 60% of CIP and 40% of RTV silicon rubber. The higher the current, the higher the force experienced by the MRE specimen. This response in higher MRE effect and tensile strength from the MRE as the linkage between rubber matrix and magnetic particles are stronger and orderly arranged. For the various compositions, the data provides a result of the highest maximum force of 5,838.24 Newton at the first peak of impact when the MRE is consists of 60% of CIP and 40% of RTV silicon rubber. That's all from me. Thank you for listening.